All right, chapter 5, section 4, isosceles and equilateral triangles. Again, this will not be on your quiz, but this will be on your test. Isosceles and equilateral triangles. Isosceles and equilateral has to do with the sides, not the angles. So just be aware of that. We're looking at sides of triangles. Isosceles is when it has two sides that are congruent, and equilateral is when it has all sides that are congruent. So looking at this, parts of an isosceles triangle. Information you have to know on this is your two legs are the two congruent sides. Okay, so my legs are congruent. I'm actually just going to write the symbol. Sides, okay, so that's this one right here and this one as well. Okay, you have one more side, and that is called your base. Your base is not a congruent side. Something you also should know is your base does not have to be the bottom. Does not have to be the bottom. Okay, does not have to be the bottom, so just be aware of that. This could be an upside down triangle, then the top piece would be considered your base. Again, it does not have to be the bottom of the triangle. Now you have two things called base angles. Something you need to know about your base angles is that they are opposite of the legs. Base angles are opposite to legs. What does it mean to be opposite? Looking at these arrows, look kind of how they're pointing. Here are my legs right here. This angle is opposite my leg. Okay, so it's pointing towards the leg. Something you should also know is your base angles are congruent. Okay, your angles are going to be congruent angles. So if your legs are congruent, your base angles will also be congruent. All right, base angles theorem. Please pay attention to the verbiage of what's written here. Highlight it if you need to. If two sides of a triangle are congruent, then the angles opposite to them are congruent. So pay attention to where this one's going. Base angles theorem. First, it's stating you have two sides that are congruent. Here are my two sides represented by my symbols. If my two sides are congruent, then that also means these angles right here are also going to be congruent. This is base angles theorem. I'm going from sides to angles. If my sides are congruent, then my angles are congruent. So be aware of that. These are my sides to angles. You could also shorten this if you want. And you could write, write base angles theorem. Okay, that's just me shortening it. But I'm going from, if my sides are congruent, then my angles are congruent. Now look at the next one. This is converse. Keep in mind the converse means it's switched. Again, look at the verbiage. If two angles of a triangle are congruent, then the sides opposite are congruent. So looking at this one, I'm going from my angles, which they're giving me right here. They're saying if your angles are congruent, then that must mean your sides are going to be congruent. So the last one for base angles theorem, it's going from sides to angles, but for base angles theorem converse, I'm now going from angles to sides. if my angles are congruent, then my sides are congruent, and this one is converse. Okay, so you're just switching the order. All right, corollary to the base angles theorem. This is pretty easy. If a triangle is equilateral, then it is equiangular. Corollary to the converse of the base angles theorem. If a triangle is equilateral, then it is equiangular. Okay, just so we are aware, equilateral has to do with your sides. It has the word lateral. And then equiangular has to do with the angles. Okay, so corollary to base angles theorem. If a triangle is equilateral, then it is equiangular. So I'm going from sides to angles. And then the converse is going from angles to sides. So don't forget what that word converse means. All right, looking at these examples, they want us to find the value of x. So looking at this one, can anybody tell me how do you think I would find the value of x? First, look at it. We know that these two sides are congruent, this side right here and this side. How do you think I would find this, Jonah?
You would do 180 minus 30 and then divide that by 2.
Good. So both my angles right here are going to be congruent. How do I know? Because they're opposite. Let me kind of draw a little better. They're opposite of my congruent sides. So I would first do 180 minus 30. I'm going to get 150. And then take that 150 and divide it by 2. And I'm going to get 75 degrees. So that means both these angles is going to be 75 degrees. That one wasn't too difficult. Okay, questions on A. All right, let's go ahead and go to B. Looking at B, I know that my two angles are congruent. So I'm actually just going to go ahead and label this A, B, and C. Which two sides would be congruent? Yeah.
Angle A and then angle BC.
AB is going to be congruent to BC. Good. How do I know? Again, they're opposite of my angles. So this side is going to be congruent to this side. So I'm going to go ahead and set them up as if they're congruent to each other. 2x minus 4 equals x plus 5. And I'm going to go ahead and just solve it. So subtract x from both sides. I'm then going to get x minus 4 equals 5. Going ahead and adding 4 to both sides. And x equals 9. Did I need this side over here? No. Okay, this is just added information to kind of throw you off. So we do not need. Okay, we do not need this side because we're able to determine it given the other two sides. So that's just information that's added that you don't have to solve for that x because we already solved for x. All right, and then looking at the last one, C. It looks like it's an equilateral triangle or equiangular triangle just by looking at it, but you can tell it's not because my measurements are different. Now I need to determine, is it a isosceles triangle? Okay, meaning are my two sides congruent? So I first have to look for my angles. Is this angle congruent to any one of these measurements here? So this is what I'm going to go ahead and find first. So looking at this one, I'm going to go ahead and I'm going to solve it. I'm going to add 56 plus 62. I'm going to get 118. And then I'm going to solve 180 minus 118. And I'm going to get 62 degrees. So if these two angles right here are congruent, again, I'm going to label ABC. Which two sides would then be congruent? Yeah?
42.
Good. So the sides that will be congruent is side AB is congruent to AC, which makes x equal 42. Oops, not degrees, just 42. because it's a side. Okay, so be aware on how I'm determining what's congruent. So yeah, remember that when you're finding the congruent sides, it's the opposite ones. Think of it as, what is it pointing to? What side of my vertices pointing to if you were to draw an arrow from there? So it's the opposite sides that are going to be congruent, so not the 41. All right, this question says, place statements in appropriate order for a proof and provide the reasons. So they already kind of gave us our statements. We then have to give our reasons. So I'm going to do it right under here. Or you know what? I'm not going to do it there. I'm going to go ahead and just put it right here so I could see it. All right, I know there's that little image there, but just try and follow along. So I have my statements, I have my reasons. They're saying given angle 1 is congruent to angle 2, so I'm just going to go ahead and mark that. They want me to prove that my sides OK and OJ are congruent. So my first statement is going to be angle 1 is congruent to angle 2. How do I know it's given? All right, next, looking at it, what else do I know is going to be congruent? Can anybody tell me what else do I know is going to be congruent? Okay, angle 1 and angle 2, yeah.
The vertical angles.
Good, the vertical angles. So angle 3 is vertical to angle 1, and angle 4 is vertical to angle 2. So looking at my options, it is there. I'm going to go ahead and write angle 2 is congruent to angle 4. And angle 3 is congruent to angle 1, and you gave me my reasoning. Vertical angles theorem. All right, next. Since I know that the vertical angles are congruent, what else can I show that's equal? Yeah.
Angle 3 is congruent to angle 4 by the transitive.
Okay, what's another word for transitive? Substitution. I would use substitution. So angle 3 is congruent to angle 4. It's a little hard to see. And then how do I know that? Because I'm substituting. I'm sorry? Oh, you're right. I wrote this one incorrectly. This one should be, no, it's angle 3 and angle 1. It's kind of hard to see. This is angle 1 right here. Let me erase it and put it in black. This should be angle 1. I wonder if I could move this. I guess I'll just put it right. Nope, that doesn't even do anything. We'll just leave it there. Okay, and then the last one. I'm sorry, it is a little hard to see. I shouldn't have wrote it in the little diagram. The last one is going to be OK, not angle OK. Segment OK is congruent to segment OJ. And how do I know? If I stated that these angles were congruent, because my angles are congruent, I know the opposite sides will be congruent. And what theorem is that? I'm going from angles to sides. Yeah.
Converse of the corollary base.
Not corollary. It's just base angles theorem converse. I know it says converse to base angles theorem or converse base angles theorem, but you can put the converse at the end, that's fine. Base angles theorem converse. Okay, so if it's a little hard to see, I'm going to number it at the side. This was 1, 2, 3, and then this one was 4. So just so you're aware of what goes where. And then you should be able to see the reasons. All right, questions on this one? Okay. All right, this last one is just asking for a proof by itself. So going ahead, and I'll make my t-shirt right here. It's white, so you guys will hopefully be able to see it. I have my statements. I have my reasons. I'm going to go ahead and start with the first one. M is a midpoint of A and B. And then I'll also write angle M, or the measure of angle 1 is congruent to the measure of angle 2. And this is all given. Okay. Key thing with proofs. Anytime you see that something has midpoint, almost always you're going to then get definition of midpoint. Okay, so whenever you see that midpoint, you're always going to get some sort of definition of midpoint after. Okay, what's the definition of midpoint? Can anybody tell me? What's the definition of a midpoint? What does the midpoint do? Yeah.
It splits a line into two congruent sides.
Good. It splits that segment into two congruent segments. So what do I know? I'm now going to write segment AM is congruent to segment MB. Okay, so just be aware of that. Anytime you see midpoint, definition is going to come somewhere after. Okay, looking at the next one. 3. They gave me already angle 1 and angle 2 are congruent. And because those two angles are congruent, what can I state is also going to be congruent? Yeah.
Side AM is congruent to side AC.
Good. So because those angles are congruent, I can now say AC is congruent to AM. How do I know that? I'm going from angles to sides. How do I know that those are going to be congruent? Yeah. Good. Base angles theorem. Converse. All right, now that I know that, I can go ahead and say what I'm trying to prove. AC is congruent to MB. How did I get here? How did I get there to 4? What was it? Good, substitution. Do we have any questions on this one? All right, again, you'll get the homework for this later and it'll be due on Monday. Your quiz is on the 18th, Friday. It is a half day. This section will not be on the quiz, but it'll be on the test, okay? There are 2 reviews on Canvas. Look over them, complete them. You guys have quite a few days to study for that quiz. And it is the first quiz of the second quarter. So please make sure you are studying.